Everyone's familiar with the five senses, since these are the most basic methods of how we interact with the world. That's perception. However, there's this thing called visual imagery, where humans become wizards and can create something out of nothing in their minds. This is done by mentally picturing objects, scenes, and other mental images and manipulating them, interacting with the objects as if they were actually a part of the real world. Let's break it down.
A mental image is a quasi-perceptual experience. This means it's kind of like perceptual experience, but occurs in the absence of the appropriate external stimuli. In other words, anything you could think about that isn't directly in front of you. A form of mental imagery is visual imagery. A visual image is a mental representation of an object or scene that is pictured to scale. For example, you can use your imagination and create things that don't exist in reality, like a flying pig, while also preserving spatial measurements, like when you imagine a rabbit and an elephant standing next to each other, with the rabbit being much smaller, just like you would see in real life.
Who came up with this theory of visual imagery, though? Coslin and Schwartz. They're theorists in cognitive science. Their theory is both functional, as in it describes what the brain itself does with the images, and general, meaning it tries to account for all the operations used to form the mental image. This theory can be split into two parts. First is the structures involved in the construction of the mental image, while the second is the process of interacting with the image to either transform it or gain information from it.
First, take the structures by themselves, a group which can then be separated into two categories: surface representation and deep representations. Surface representations are kind of like if you took a photo of the mental image. It occurs in a medium known as the visual buffer, which is an arrangement of points similar to those that make up a computer monitor. Images here are short-lived and vary in resolution. The latter means things in the center focus are clear, and things towards the edges of the image are blurrier. Another aspect of image structure is deep representation. This is the name of the rules used to figure out how the surface representation pieces fit together and interact with one another.
Break deep representations down even further, and you have two things: literal encodings and propositional encodings. Literal encodings are the list of coordinates for how to place individual parts of the object in the surface representation. Propositional encodings are the declarative sentences that contain information about the object's parts. For example, where is each piece, or how big is each piece? Imagine you're assembling a chair. The literal encodings would be the instructions on how to assemble all the pieces together, while the propositional encodings would be descriptions of what each individual part is.
Now you know what makes up visual imagery. But how do all these bits and pieces start coming together in the first place? Well, there are three different components of image processing. The first is image generation. This step involves taking parts of an image and bringing them together to form the complete image. Here you literally take the building blocks of an image and assemble them together, with more complex images taking longer to assemble. The next step is called image inspection. This step is where you are able to look at the image you formed and answer questions about certain aspects of the image.
For example, imagine that you were asked to visualize a rabbit and an elephant next to each other. Now say I asked you if the elephant had a tail. How did you imagine that tail? Did the image of the elephant's tail instantaneously pop into your mind? Or did you picture the image of the elephant getting bigger, as if you were zooming in closer to it, like with a camera lens? Chances are that you zoomed into the tail. Now imagine that I asked you if the rabbit had a tail. Did it take you longer to bring up the picture of the rabbit's tail? Since your visual images have scope extent, the rabbit is formed smaller than the elephant, and therefore you need to zoom in more in order to see its tail.
Another example to show the spatial extent of visual images involves viewing a picture of an island. Say that there are 2 points on the island. The image of the island is taken away, and then you're asked to map the distance between the 2 points. The greater the distance between the points, the longer it takes to complete the task. The last component of the visual image is image transformation, of which there are 2 different types. The first is blink transformation, where the image can be moved or changed instantaneously. The second form of image transformation is shift transformation. With shift transformation, the image is not changed or moved instantly. Instead, it is slowly rotated over a period of time. An example of shift transformation is Shepard and Metzler's cuboid objects. In this experiment, you are given different cuboid objects with another one pictured underneath. Then the person is asked if the image below is the same as the image above, only rotated. The larger the degree of rotation between the first and second objects, the longer it would take for the participants to answer, as if they were taking time to literally rotate the objects in their head.
So, what have we learned so far? In a nutshell, visual imagery can be broken into two categories: image structures and image processes. Image structures consist of surface and deep representations. Deep representation consists of literal encodings, what are the parts, and propositional encodings, in other words, how do the parts fit together. Image processes, on the other hand, consist of three categories: image generation, so forming the image in the first place; image inspection, answering questions about the image; and lastly, image transformation, or manipulating the image.